Hello, I'm JW, and in this video, metal consumer units, which, as you've seen in the previous video, are going to be pretty much the standard thing rather than the previous plastic ones. And metal consumer units are fine, but they've typically not been used on TT supplies. Those are the ones where you have an earth electrode or earth rod in the ground rather than using the supplier's provided earth. And the reason for this is due to the earth loop impedance, which is considerably higher on that type of supply. And the problem that could occur is the incoming wires from the supply could short onto the metal case of the consumer unit, and in that case it wouldn't actually blow the supplier's fuse because the impedance would be too high. But of course, with plastic consumer units being obsolete or no longer permitted, then it's going to be pretty much a metal one that's going to have to be used. So I'll have a look at the potential problem there, and also some of the solutions which can be used so you can actually use a metal consumer unit on a TT supply. So a quick reminder then of the layout of a TT supply. So you've got your transformer, which is from the electricity supplier, and from there of course you've got your two wires going into your property, and you're going to have the line and the neutral, so we'll call the say line there and neutral there, but so it doesn't really matter which way on they are, and your consumer unit of course over here. And of course the wires will come in and you're going to have a supplier's fuse, typically sort of 80 amps or 100 amps or something. And there'll be an electricity meter there, which we're not going to show in this case. And of course those wires will then go into your consumer unit and connect to whatever you've got inside there. Now the earth on these is not provided from the supplier, that's actually something you have to provide yourself. So what that actually is a earth electrode in the ground. So that's generally a copper or steel rod or whatever, actually located in the ground. And your earth wire will connect to the electrode there, and of course that will go to your consumer unit as well. And if it's a metal one, it will actually connect to the metal frame of the consumer unit as well as the circuits and whatever else inside. And the other connection, of course, is way back at the transformer, and that's something the supplier would provide, and it's going to see another connection from here to another electrode in the ground. So if there's any kind of fault, so for example the line here shorted onto the earth inside there, for example, the path of the current flows from the transformer via the supplier's fuse through here and into the actual ground, and then it's got to pass all the way back through the ground, back to the other electrode and back to the transformer. And the impedance or resistance of that is going to be considerable because it's actually passing through the mass of the ground. There's no direct metallic path to create a reasonable fault current. And the upshot of that is that the fuse isn't actually going to blow, because that typically might say be a say 80 amp fuse. And even in the best situations, the impedance of this path is going to be something in the tens of ohms range, and let's just say for an example it was actually 10 ohms, which would actually be a remarkably good kind of connection, typically to be in the sort of 50 to 100 ohms range or even higher sometimes. If you've got a supply voltage say of 240 volts, 10 ohm fault path, and the current therefore is 240 divided by 10, which in this case is 24 amps. And of course 24 amps through an 80 amp fuse is obviously going to do nothing. It's just going to power that all day long, electrodes sizzling away in the ground forever. And this means that this metal consumer unit and any other metalwork connected to it is going to be pretty much at mains potential, because the bulk of the impedance is here. So 240 volts on this metal consumer unit, and of course any other metal items connected to it, including all of the circuits within the building, so things like metal light switches, the screws that hold sockets in the wall, cases of your washing machine and toaster, and of course anyone touching those is going to get a severe electric shock and possibly be killed. And I say this situation will continue indefinitely until someone actually notices and cuts off the supply at this point. Now, of course, in the real world, the consumer unit will, of course, have an RCD in it, and in some cases more than one, or even a whole series of other similar devices. So if we've got the line units coming through the RCD, and then there's some fault between the line and earth here, the metal case, they're not a problem because the RCD, of course, will switch off and therefore disconnect this here, and of course avoid this dangerous problem of the live metalwork actually existing for any more than a fraction of a second. So that's all very well and fine. But the real problem occurs is when the fault isn't on this side of the RCD, it actually occurs back here, for example, where the line might pass through a hole in the metal consumer unit. Like say a sharp edge there, and the cable just got moved a bit, and it creates a fault at the point it enters the metal consumer unit. So you've still got that line shorting onto the metal casing, and of course this RCD is not going to do anything because the fault is before the RCD, so as far as this is concerned, all is well. And that's the thing you want to avoid, and that's really why metal consumer units have not typically been used on this type of supply, because the risk of this happening and sort of electrifying the entire metalwork in the installation, it's of course something you do not want, and the RCD inside is not going to help you. Now, one way that this problem has been prevented in the past, and theoretically still could be, is to fit another RCD before the consumer unit. And of course this then will disconnect because the fault is again downstream of the RCD there, and in the past these were those earth leakage circuit breakers which were voltage operated, but again that would serve the same purpose. And in order to make sure we haven't just moved the fault from here to here, this RCD would have to be in a plastic enclosure, and that of course wouldn't have the problem then of wires shorting onto the metal case, because of course it would be insulated or made of plastic. And obviously you could do the same thing here by having the plastic consumer unit, but of course as we saw in the previous video, plastic consumer units are really not going to be happening anymore. But the problem is you can't actually do this anymore either, because although this is only an RCD in a box, that also comes under that same regulation. So in order to comply, this one would also have to be put into a metal enclosure, and of course all that's done is move the possibility of the fault from here to over here. And if the fault occurs there, then the same problem has occurred, because this would be metal, and of course it would have an earth connection, just the same as anything else. Now, one other possibility is to place all of this, or just the consumer unit, have a plastic one, but then place it inside of a cupboard or something which was made out of non-combustible materials. Unfortunately, the choices of materials for making cupboards out of that are non-combustible will probably come down to metal, and of course then once again you've got to have a hole in the side of the metal cupboard where the cables can come in, and of course that's the same problem as you had before, so no help there. In theory you could have the wires coming back in through the wall, for example, and have it surrounded by masonry or cement, and then coming into the back of the cupboard and have a sort of metal front on it, but really this is going into the realms of fantasy, and a considerable amount of construction work will be needed there just to avoid a problem occurring like this. And before we look at the solutions to that, just a quick example here of why it doesn't happen or isn't a problem on other types of supplies, such as TNS or TNCS, because on those you've actually got a metallic path, either as part of the cable or in some cases part of the neutral. So in the event of a fault here onto the metal case, current will flow via the case to the earth here, and it's actually a full metallic path all the way back to the transformer, and generally via an extra conductor in the supply cable. Also in some cases it uses the neutral, but of course the impedance to this is going to be dramatically less, typically less than 1 ohm, in some cases a lot less, but even at 1 ohm the current which would flow on a 240 volt supply, 240 divided by 1, which obviously is 240, and of course that's more than enough to blow the incoming supply's fuse and of course disconnect the supply and remove the danger. Now, as I mentioned in the previous video, the Wilex catalogue for this year has now been published, and here's a page from it. And as you can see, the consumer units they're now offering are fully metal, and therefore will of course have this problem if you're going to use it on a TT supply. And notice also that the cover, the hinge thing there which just goes over the circuit breakers, is also made of metal, which kind of implies that all those metal ones currently on the market with a plastic cover, typically transparent, will of course be no longer any use, because that means you've got a big hole in the front where you've got your plastic circuit breakers with a plastic cover over the front, both of which are probably flammable, so that's really no good either. And if you have a look on this page, they're actually now providing a metal cover which is intended to go over existing metal units which have the plastic visor and hinges, as it says there, so at least you can possibly upgrade some existing ones to the new all-metal design. But unfortunately, of course, there's going to be plenty of others out there which have the plastic front visor, and of course theoretically those are not going to be compliant. Now the previous item here is certainly interesting, which is something they've provided where you've got a TT supply, and this is supposed to prevent the cables from shorting onto the metal case where they actually enter. And as you see, it's a very large plastic gland there with the lock nut and whatever to secure it into the case, and it has this insert which is designed to take the two incoming supply, the line and the neutral, and it appears to be available in both 16 and 25 square millimetre sizes, and this fits into a 32 millimetre hole as it says there. Now this is probably going to do the job in terms of not allowing cables to short onto the metal casing, because it seems to be made out of a what looks like a very hard type of plastic, so no danger of its metal edges sort of slicing through as they might do with, say, a rubber grommet, for example. But even if you're going to fit one of these, that still leaves the possibility of the cables inside the consumer unit actually creating a fault to the metal case. So although this may go some way to allowing these to be used on TT supplies, it's certainly not an ideal solution, and of course there is still the possibility of that type of fault occurring. And just for comparison, here's the Crabtree catalogue, and it's basically exactly the same. We've got those all metal consumer units in there with the metal visor over the various protective devices, and hardly surprising because Wilex and Crabtree are in fact part of the same company. So for those two brands at least, it's going to be metal everything, and the plastic one simply will no longer be available. So if you use that plastic gland item that we saw there, it would look something like this. You'd have a 32 millimetre hole in the side of the metal consumer unit. The plastic gland would fit through, and of course inside it has that large washer type thing which would keep the cables separated, and obviously support them as well, so that certainly at this point at least there's no danger of these cables being damaged and then shorting onto the metal casing at either side. But of course that still doesn't prevent any issue if the cable inside here became damaged and say short onto the metal casing or the back of it or whatever, because you're still actually before any of the protective devices within the consumer unit. And although things like that are probably fairly rare, it's certainly not impossible, particularly if there was something say inside which overheated and caused the insulation to be damaged. And of course that exposes live wires which then could easily have shorted onto metal components inside. So look at the problems with a metal consumer unit on a TT supply, and certainly one manufacturer's part solution to the problem, because though that gland type grommetty thing is obviously going to prevent the cables shorting onto the case where they enter, it still doesn't address the issue of the cables inside before they actually get to the RCD or whatever devices you have in there. And although that's a fairly unlikely scenario, it's not impossible. Say for example there was some overheating inside causing the cables to be damaged, or say some other problem occurred in there and it just needs those to short onto the metal case, and they've got that live metal work throughout the installation. Now other manufacturers are likely to do similar. Hager, for example, have already published a catalogue with all metal consumer units in it, and they're very similar to the others with the full metal construction and the metal visor to go over the front. MK haven't actually issued a catalogue, but they have put out a release stating that they're going to be making all metal consumer units in the future. So of course basically the same kind of idea, and pretty obviously other manufacturers are going to go down the same line, and certainly the issuing of non-combustible plastics does not seem to be something that's even considered at this stage, so we're going to end up with metal or nothing. So until next time, thanks for watching.